How many Americans drive electric vehicles, EVs? And have the numbers been going up, and where? Well, in the latest Bamboo Weekly, I asked you 6 questions having to do with EVs in America in the wake of Trump's budget basically getting rid of any subsidies or tax benefits for buying EVs. So I decided to look at data from the Bureau of Transportation Statistics. That's part of the US Department of Transportation. And you can see if we go to their website, we have a nice table here with information from 2016 all the way through 2024, both for the overall US and for each individual state. So I downloaded this, and it's a little tough to figure out how to download it. You click on this, choose a format to download, and then you can get it in either CSV or Excel format. I got it in Excel format, and it looks like this. We can see here that I have a column for each state or the whole United States. Then I have a column for the type of vehicle or count that we're doing, and then we have other columns for 2016 up and including 2024. Okay, great. So we've got that. How can we solve some problems? And the first question that I asked is for you to read the Excel file into a Pandas data frame using the first and second columns as the 2 parts of a multi-index. So I'm going to first say import pandas as PD, as we usually do. And I'm going to say also the file name equals, and I'm going to say here, users, Reuven, Bamboo Weekly. It's going to be under notebooks. It's going to be under BW126. And here we go. Oh, data, BW126. Okay, and I've got the Excel file. So I can just say df equals pd read CSV, read Excel, not read CSV, it's read Excel, it's an Excel file, a file name. And if I do that, we see that actually it works just fine. I managed to get a data frame from the Excel file, and it maps to the Excel file perfectly. There's just one little weird thing here, which is we see that all of the columns have names, except for the second one, which is called unnamed one. And you might remember, we even saw this when we looked at the Excel file, that particular column didn't have a name. So when it doesn't have a name, Pandas reads it in, just calls it unnamed, whatever number it is, starting at 0 on the left for the first column and going on from there. Yeah, but I want to make state and this unnamed one column into a 2-part multi-index. How can I do that? Well, one way, of course, is I can say set index, and I can say here with state, and then unnamed, can't spell today, 1. And I do this, and it works just fine. We now see the multi-index there. But do I really have to and want to do that? Probably not. It's much better, I think it's cleaner, to say index call equals, and then in the read Excel call, and I say basically which column or columns do I want to be my index. I want more than one column here, so I'm going to say here state and unnamed one. Here, this time I was able to type it correctly, and I load it up and I get an error. What's going on? Why did I get an error here? And I'll tell you, the error is actually super not obvious, especially if you look at the error message you get. Type error. List indices must be integers or slices, not stir. What in the world is it talking about? And the problem basically is that this column name, this unnamed one, that Pandas gave us because there was no name, doesn't exist at the point where we're doing index call. So I can go back to what I did before with set index, or I can say to index call, you know, I'm just going to count it. I'm going to say 0 and 1. I'm going to use the numeric indexes of those columns. There are other ways to do it. Like, for example, I could set the names of the columns, but then I have to set them for all of them, not just for one. In any event, if I say index call equals 0, 1, now we have exactly what we wanted in one method call. I call read Excel on the file name. I say index call equals 0, 1, and we have, sure enough, a data frame with 2 parts to its multi-index, state and this other unnamed thing. And then all the rest of our columns are now integers and floats from the years 2016 to the year 2024. Note that the year 2024 only has EV consumption, electric consumption. It doesn't have any of the data for the other kinds of cars, so we're going to have to think about that when we answer other questions. And indeed, our second question here is, using Seaborn, create a line plot showing the proportion of EV registrations each year for which we have data. So that's 2016 through 2023, okay, for the entire US. So how are we going to do this? Well, I'm going to do some method chaining here. I'm going to start with df. I'm going to say .lock of United States. And notice that I'm using the outer part of this multi-index, which means that if I use the outer part, I'm going to get back what? That's right, I will get a new data frame back where the inner part of the multi-index is the index, right? So I had a 2-part multi-index, now I have a 1-part non-multi-index, unit index, I guess we could call it. And here we have all that. So we only have US data now. But the thing is, I don't want the 2024 data. So what can I do? Well, one option would be for me to say, I know, I'll say .lock, and I'll use a 2-argument version of .lock. I'll say here .lock, and I have my, this is my row selector. And then I'll say my column selector should be, and we'll say here range from 2016 to 2024. Remember, it's up to and not including, so it won't include 2024. This looks great, right? Except this will also give me an error. And the problem is that our column names are strings. They are not integers. So it says none of these things are in the columns. And indeed, if I say df.columns, we're going to see that the columns are all strings. So I could convert this range to strings or something, but I'm going to like be a little lazy here. I'm just going to say, you know what, let's just use the row selector of .lock. And then I'm just going to say here drop or columns equals, and I'll say 2024. I should add, this is a relatively new thing, or at least relatively new for me in Pandas. It used to be that you would name the column you wanted or columns you wanted to drop and then say axis equals columns, but now you can just say columns equal and list the columns that you want to drop. I do this, and now sure enough, we have only US information with its 1, 2, 3, 4, 5, 6, 7 rows, and we have all the years from 2016 through 2023. We got rid of the 2024 data. Okay, so far so good, but that's not quite what we want. We now only are really interested in EV registrations and total vehicle registrations because we want to know the proportion of EV. So I'm going to now use .lock, and I'm going to use .lock with, as usual, square brackets, but I'm going to use a list of rows in those square brackets. I'm going to say here EV registrations. I'm going to say here total vehicle registrations. And just a very, very short rant here about look how inconsistent these names are in these indexes. EV registrations, EV is all caps, fine. Registrations is in lowercase. Total vehicle registrations, like some of the others, actually has a capital R for registrations. It's inconsistent. It's kind of annoying. Nothing you can do. That's the way it works in the world of data. And now we see that I've managed to pare it down to a data frame with 2 rows and 2, 4, 6, 8 columns. Okay, that's pretty good. How can I now plot it? Well, I can't yet because I have to know the percentage. I want to divide EV registrations into total vehicle registrations. And the easiest way I think we can do that is actually going to be to flip it. I'm going to say .t to transpose it. And this gives me now the years as the rows and EV registrations, total vehicle registrations as the columns. How is that going to be useful? Because now I can say %% change. Wait a second. No, I can't yet because I don't want to look at that. I actually want to divide it. How can I divide it? Well, I can say here .assign. I'm going to say assign EV PCT, right? This is going to be my percentage here. So I'm going to use assign, and that creates a new column. So this is going to be, I'm going to give it a lambda df. That's the data frame we got from the transpose. I'm going to say df of EV registrations, making sure that it's lowercase, divided by df of total vehicle registrations, making sure it's uppercase. Right, so that will give me then that percentage, and I can do times 100, and then it can be a real percentage number. And if I do this, look, now I have a 3-column data frame where the third column is the percentage of EVs that we see overall in the United States. We can even see that it's going up. How much is it going up? We're going to see in just a moment. Then I just want that last column, so I'm going to grab it with EV PCT inside of square brackets. Now I have that. Now it's a series because each column is a series. And now I want to plot it. Now I could say .plot.line. There's nothing wrong with that. I get a nice line plot. But I'm really partial to sometimes using Seaborn. I haven't used Seaborn in Bamboo Weekly in a while. So I'm going to say here import Seaborn as SNS. But then I'm sort of faced with a problem. And the problem is that Seaborn has its own functions. It's not run through methods on my data frame. So here I use the .plot.line method on my data frame, but I don't have that for Seaborn. How can I deal with it then? Well, I can use the pipe method. And pipe lets us pass a function to our data frame almost as if it were a method. So I'm going to say here pipe. I'm going to use lambda s underscore. So I'm going to use a lambda and anonymous function. And I'm going to say then SNS line plot on x equals s underscore index and y equals s underscore values. So what's happening here is I'm going to use the SNS line plot function, handing it the data that we got from the series. That was the result of EVPCT. That was the result of all these machinations here. And sure enough, I run it and I get a nice plot. That looks very similar to what we would have gotten through Pandas regularly. But again, I like Seaborn. And if we look at it, we can see indeed that it goes up and up and up, but then it takes a really sharp turn, right? Starting about 2021, we see many more EVs, but it only gets to about 1.2%, which if you've ever traveled in Europe or many other countries, that is a tiny, tiny number of EVs in the US compared with those other countries. And so we can probably expect, given this latest budget, that the growth in EVs will not be that huge, certainly not compared with other countries. All right, I hope that this was interesting and useful. Please let me know what you think about any of this, whether it is reading from Excel, whether it is transposing, whether it is using pipe, whether it's using lambda or lock or any of the other fun stuff. Let me know what's confusing you. I want to help you out. Leave comments. Don't forget to like and subscribe. Let other people know about Bamboo Weekly and about these videos. And I'll be back real soon with lots more about Python and pandas and everything in between. See you then.